Hello, in our lecture of rocks today, we will continue talking about types of igneous rocks, and today we will talk about plutons. So last time we have been talking about cells, dikes, and other structures of igneous rocks, and today we will talk about plutons, and they are generally much larger intrusive body than any others, and they have intruded much deeper in the crust. And usually they show sharp contact with the surrounding rocks into which they intrude. But in depth, you will see them having like the gradational contacts with other bodies surrounding this. First thing of plutons here we will study is lobulith. And lobulith, as you can see from the figure on the right side, they are relatively small plutons that usually show a concave downward upper surface. And you see this curve. Why? I tell you why. Because the weight of overlying rocks causing collapse into the space once occupied by the magma. So you see the shape resulted from reduction in the volume that occurs when magma crystallizes, and then it goes down from the top. That's why it creates this concave shape. Other types of plutons are batholiths and stocks. Batholiths, very large intrusive bodies. You see them on the bottom here in the figure. They can even range more than tens of kilometers. And also sometimes composed of several smaller intrusions. So smaller intrusions, they can collect each other and form a bigger batholith. So how about stocks? Stocks are smaller bodies than batholiths. They are fed from deeper batholiths. So their contentive magma comes from the batholiths. You see them on the top of batholiths here, stock. And they have been feeder for volcanics. They feed the volcanic eruptions. But because large amount of erosion are required to expose a stock or batholiths, the associated volcanic rocks are rarely exposed. And the figure on the right shows that very well. Okay, now we come to the volcanic extrusive igneous rocks. We were talking about intrusive, including plutonic rocks. Now we will talk about rocks on the surface of the earth, which we call them extrusive volcanic rocks. And magma are generated deep within the earth, begin to rise because they are less dense than the surrounding solid rocks, because they are liquid. But when they rise up, they encounter depth or pressure where dissolved gas no longer can be held in solution. So the gas escapes, and the gas begins to form a separate phase, and it makes bubbles. Okay? And when these bubbles are formed, they will also continue to grow in size because the pressure is getting reduced and more gas comes out of solution. And if the liquid part of the magma has low viscosity, means that the viscosity is very low, then the gas expands easily. Takes its time to expand. When the magma reaches the surface, the gas bubble will simply burst and it will expand to atmospheric pressure. Then it will go out of the magma easily with non-explosive eruption, usually as lava flow. So here, this mechanism of gas movement will just allow us to see only lava flows, not explosions. If the liquid part of the magma has a high viscosity, which is different from the last case, then the gas will not be able to expand easily. So the pressure will build inside the gas bubbles and keep building. When the magma reaches the surface, the gas bubbles will have a high pressure inside, which will cause them to burst explosively and make this explosion of volcanoes, as you see from the figure. this will cause an explosive volcanic eruption. Now we will talk about the textures of igneous rocks. The main factor that will affect the texture or the fabric of the rocks is the cooling rate. This is the main factor. But is this the only factor? No. We have other factors also that affect the creation or the form of textures. The diffusion rate, at which atoms or molecules can move through the liquid, and the rate of nucleation of new crystals at which enough of the chemical constituents of the crystal can come together in one place without dissolving. The last factor is the rate of growth of crystals at which new constituents can arrive at the surface of the growing crystals. Of course, there are some other factors, but this is the important factors we need to know about. Okay, let's see what kind of textures we have in igneous rocks. Sometimes if we have two stages of cooling, the slow cooling, this will allow growing of few large crystals, followed by rapid cooling to grow many smaller crystals. This will result in creating a porphyritic texture with two or more distinct size of grains, smaller ones and large ones, as you see from the figure. Sometimes also if you have only one single stage, that can also lead to producing a porphyritic texture in different location, of course, deeper and shallower. In porphyritic texture, the large grains are called phenocrysts, and the material surrounding phenocrysts, which we call sometimes a matrix or ground mass. As you see from this figure on the right here, we will learn about the fabric now. Fabric actually is just a mutual relationship between the grains. Bigger grains, smaller grains. So if most of the grains are euhedral, they have a complete form of crystals, that is, they are bounded by well-formed crystal faces, we call this idiomorphic granular. This fabric is idiomorphic granular. If most of the grains are subhedral, they don't have a complete faces, then we have a fabric called hebediomorphic granular. And the last one, if we don't have really good shapes of crystals and we call it anhedral, then the fabric here is allotriomorphic granular. Next lecture, inshallah, we will talk about the classification of igneous rocks. See you then. Bye.